Good day.
Today we will talk about cargo handling and stowage.
The intended learning outcomes, the students must be able to describe.
Loading. The safe operation of bulk carriers is dependent on not exceeding allowable stress in the cycle of loading, discharging, ballasting, and deballasting. Unloading.
Stowage plan, a plan showing the distribution of all cargo parcels stores on board of a vessel for a voyage. A plan presenting the quantities and description of the various grades in the ship cargo tanks after the loading is completed.
Securing care during the voyage. The aim of ship's officer and crew members on board should be to prevent damage or deterioration whilst the cargo is under their care and to deliver it as far as possible as in good condition and order as it was when received on board.
Here are some instruments that can be used to check the cargo. Thermometer, used to check the cargo temperature. Water finding paste to check if the cargo tank has water.
Now, we are going to prepare the stowage plan. We will take the tanker vessel as an example. Stowage plan require the density, temperature, cargo quantity, draft, and the tank to be used. Cargo operations are carried out in accordance with the cargo plan. Always follow the loading and unloading sequence.
Overloading.
This is the example of stowage plan. Any steps depart from this might damage the vessel stability. Prior loading. All cargo operation in tanker vessel require utmost diligence in planning and most careful consideration will need to be made for a safe operation. The loading plan shall be posted on cargo control room at a conspicuous location and distributed to all personnel directly involved in the operation. The loading plan should be signed to confirm the personnel have read and fully understood the plan. Inert gas operation. Tanker vessel using the inert gas system should maintain their cargo tanks in a non-flammable condition at all times. When a ship is in a gas-free condition before arrival at a loading port, the tanks must be inert prior to loading. Inert gas is principally used to control cargo tanks' atmospheres and so prevent the formation of flammable mixtures.
We can see that the cargo tank pressure was rising when the cargo increased. Most atmospheric tanks require a venting device that will allow large volumes of vapor to escape under relative pressure, both positive and vacuum conditions.
Inert gas system is used to prevent the atmosphere in cargo tanks or bunkers from coming into the explosive range.
Dilution method takes place when the incoming inert gas mixes with the original tank atmosphere to form homogeneous cargo mixture throughout the tank so that, as the process continues, the concentration of the original gas decreases progressively. It is important that the incoming inert gas has sufficient entry velocity to penetrate the bottom of the tank. To ensure this, a limit must be placed on the number of tanks that can be inerted simultaneously depending on the maximum capacity of inert gas flow provided by the inert gas. The fire triangle is used to show the three elements that when present together can cause a fire to start. These three ingredients are fuel, heat and oxygen. Under all circumstances they should be kept apart to avoid a fire starting. Inert gas fire suppression systems. are based in the principle of reducing the oxygen concentration inside the protected hazard. Inert gas suppression systems are the safe, natural way to extinguish a fire. A pressure vacuum valve, also called a breather valve or a conservation vent, actually has two vents valves, pressure valve which opens to let vapor out and vacuum valve which opens to let air in. A pressure vacuum valve, also called a breather valve or a conservation vent, actually has two vents valves, pressure valve which opens to let vapor out and vacuum valve which opens to let air in. Pressure vacuum relief valve, a device which provides for the small volumes of vapor, air, or inert gas mixtures. When the cargo tank pressure becomes low, the pressure vacuum valve will close automatically and depends upon the setting value. We presumed that the vessel is at terminal and ready to receive the cargo. Open the manifold. Open the segregation valve. Open number 1 port side cargo tank. Then, you can start loading. When you observe that you are receiving the cargo in one port cargo tank, you can open the one cargo tank starboard. The trim of a ship is the difference between the forward and aft draft. When the aft draft is greater, the vessel is deemed to have a positive trim, and it has trim when the forward draft is the greater. When you observe that the forward draft is greater than the aft draft, stop loading in one port and starboard cargo tanks. Then continue loading once again when you are in even keel. Even keel, when a ship is so trimmed as to sit evenly upon the water, drawing the same depth forward and aft. When you are in even keel, continue loading once again in one wings. Open one port and starboard cargo tanks. List is the degree to which a vessel heels to either port or starboard. A listing vessel is stable and at equilibrium, but the distribution of weight aboard often caused by uneven loading or flooding causes to heel to one side. If the vessel is listing to either port or starboard side, stop loading on the opposite side where the ship is listing. For example, the vessel is listing to port. Then stop loading in port side. Continuous loading until each of cargo tank reach its final allotges. Do not forget to close each tank upon completion. Upon completion of loading, vessel will proceed to discharging port. We were informed that in Africa the temperature were higher than the loading port, so we are expecting that the cargo volume will be more. We can observe that the volume of the cargo had been expanded during voyage due to high temperature. From 95% become 97%. Tons and cubic meters denote the same physical property. Metric tons measure mass, while cubic meters measure volume. However, you can determine the amount of space a ton of specific material fills by using the mass per volume of substance, known as density. Topping up, the introduction of inert gas into a tank which is already in the inert condition with the object of raising the tank pressure to prevent any ingress of air. Be aware that during a sudden drop in the ambient temperature, it may cause to drop the inert gas pressure inside the tanks. Maintain positive pressure. Before starting of discharge operations, reconfirm all cargo tank openings are tightly closed. Cargo tank inert gas supply should be correctly set. The individual cargo tank inert gas valve key is to be kept within the control of the chief officer.
Gas system inerting must be carried out during loading, on voyage, during unloading, tank cleaning and for purging prior to gas freeing.
This is a procedure of blending the cargo or if you are circulating the cargo through heat exchanger. Operate and test the inert gas system before arrival at the discharge port. Ensure that oxygen in all cargo tanks is less than 8%, preferably less than 5%. This is some reason why the oxygen content in the cargo oil tanks was rising because of ingressing of air inside the tanks. This is an example of a container lose its pressures inside of it. It will be like a Tetra Pak when you sip the air inside of the Tetra Pak. Because inert gas helps to maintain the pressure inside the cargo tank. Monitor the cargo tank oxygen level, pressure and parameters, and temperature throughout the cargo oil discharge operations. During discharging, the monitoring of the cargo tanks not connected to the inert gas system shall and more be done carefully and more frequently. Watch the temperature. Ensure that oxygen level is maintained below 8%, preferably below 5%. Both vessel and the receiving terminal are ready for cargo operation. Start discharging. completed discharging. Thank you for watching.